So we don't just use genetic modification in plants, we also can use it in animals. So the first GMO animal that was approved for human consumption is the Aqua Advantage salmon. So it's an Atlantic salmon that has a growth hormone gene from, I believe it's Chinook salmon, and a promoter from a fish that's escaping me right now. But both the fish that has the growth promoter and the Chinook salmon, where the growth hormone gene is taken from, they both grow faster, and the other fish that the promoter is taken from grows year-round. So the idea is in these Aqua Advantage salmon that are, again, Atlantic salmon, they are capable of being ready to sell in 18 months versus a wild salmon or a non-modified salmon that takes about 3 years, so twice as long, to get to market size. These salmon, of course, are not grown in the wild. They are farmed salmon. They call it aquaculture. So there are fish farms where these are grown. There are mechanisms in place to prevent them from getting into the wild. But here, what you see, this fish on the top is the same age as this fish on the bottom. They're 18 months. This is a non-modified Atlantic salmon, and this is a Aqua Advantage salmon. So I told you they were the first approved for human consumption in the US. They were approved in 2015, but there was a lot of debate and a lot of, assurances people wanted, etc. So they weren't sold until 2021, and now they are available for purchase. We talked before about the pigs that have been modified using CRISPR for what's called xenotransplantation, basically using pig organs to put in people. Pigs have also been modified by having genes inserted from mice and E. coli to allow them to better process phosphorus. And you're like, what in the world does that do? That makes their manure less polluting. So the pigs that are able to better process phosphorus have manure that is less toxic or polluting to the environment. There are also glowfish, and those were just for funsies. They inserted fluorescent genes from different sources like jellyfish or coral into different fish species, so then you can buy pretty shiny fish. And then this picture I have on the top is maybe one that you've been looking at going, what is wrong with that cat? So this cat has been modified to express a protein called green fluorescent protein. It does exactly what it sounds like. It's a green fluorescent protein. So this cat, of course, is glowing green. And there have been lots of animals. You can Google, different GFP animals, and you can find lots of different animals that have been modified in this way. And these are really useful in animal studies to see where genes are being expressed. So for example, the article I got this picture from was about cats that had been genetically modified to be resistant to the kitty equivalent of HIV. It's called FIV, feline immunodeficiency virus. And they wanted to make sure that the gene that they inserted that would make them resistant to FIV was being expressed everywhere. And sure enough, it is, because they put the two genes together, the GFP and the anti-FIV gene. And now you can see that this kitty, he glows in the dark. We can also use genetically modified organisms in medicine and industry. I've been talking a lot about modifying plants and modifying animals, but we can also make genetically modified bacteria. A really classic example is insulin production. The human insulin gene was inserted into E. coli for large-scale production of human insulin. So that made the E. coli a recombinant organism. It's got a little bit of human and a lot of E. coli. We can use genetically modified yeast, and and other organisms as vaccines or therapeutics. So they have genetically modified yeast to produce proteins from the human papillomavirus, HPV, and those proteins can then be used in vaccination. Sometimes when we're talking about vaccinations against different viruses, they actually use the virus itself to make the vaccine, and that might be a little bit dangerous. But if you're only using a couple of proteins and you can make them in yeast, that means you can just make tons of that protein. You can make a lot of the vaccine. And in theory, that should make the vaccine more accessible in terms of there's enough vaccine to go around, but also more affordable because you can use something like yeast, which grows a lot, to make the protein. Biofortification is the idea of enhancing foods with vitamins or minerals. So, genetically modified crops, that agricultural biotechnology is a really important part of industry, but we already spent a lot of time talking about it, so I don't have to go into it in a ton more detail. And then there's also bioremediation, modifying microorganisms to better clean up pollution, like oil spills. So there are some bacteria that can naturally degrade oil. And what they're trying to show you here is like this is an actual micrographic image of bacteria that can degrade oil. They can help the oil emulsify so that you don't have these giant oil spills anymore. But maybe they're not the fastest growing, maybe they're not the cheapest, maybe they don't grow under this condition or that condition. And so scientists are working to genetically modify other bacteria to improve the capabilities of cleaning up pollution. And again, those are just some examples of using genetically modified organisms in medicine or industry. But of course, as we were going through these slides, you're probably in your head thinking about your own opinions about this. And, again, my goal is never to change your mind or to tell you one opinion versus another is better. I want you to understand the science, and then you can make your own opinion. So now you have an idea of the science behind what a GMO is and why a GMO would be created. So maybe these are some concerns that you've had, but these are concerns that do come up. The most common is about food labeling. Do genetically modified organisms or products derived from genetically modified organisms need to be specifically labeled? And so, some people hear genetically modified organism and they freak out. When I lived in Fresno, I lived really close to Whole Foods. So that was one of the grocery stores that we actually shopped at a good amount because it was so close to the house. And, very anti-GMO. Like, this is GMO free, GMO free, GMO free. And I'm like, girl, 90% of the corn in the U.S. is GMO free. It has GMOs. Your corn is not GMO free, but that's fine. But, do you think they need to be labeled? And that can get to the debate of, okay, I think it should be labeled because I want to know what I'm putting in my body. I just want to know. Okay, fine. But then some people are like, well, if they're labeling it, that means it's bad. Like, I need to avoid it because, they had to put it on there. It means it's bad. But then if it's not labeled, well, what are they hiding? Why don't they label it? I'm like, y'all, it's not a conspiracy. Do you think they should be labeled or not? A label doesn't imply that it's good or bad. It just is the label. Corporate control. Now, this is where people get real feisty, and I can get feisty in here too. For example, things like patent rights and seed monopolies. Well, you know who makes Roundup Ready plants? Monsanto. You know who makes Roundup? Also Monsanto. I don't know how much you know about plants, but plants are weird. Plants are uncontrollable. If your neighbor is growing Roundup Ready corn, what is to stop that from contaminating your corn? Not a lot. And Monsanto has been known to go in and start charging people because their fields got contaminated with Roundup Ready crops. The other thing is, it's not like I bought the Roundup Ready seeds, and then I'll just harvest the seeds from this crop and plant them next year. Nope, you are required to buy the seeds brand new every year. That is Monsanto's right. Is it right? That's for you to decide. And then pharmaceutical companies have a patent on particular drugs. And I know insulin has been in the news a lot. Certain companies have capped the cost of insulin in the US, others have not. Some lawmakers are happy with the cap. Some lawmakers are trying to repeal the cap. Again, this is why it's very important to be informed and vote, somebody who supports the issues you support. But I thought that this chart was very interesting. A unit of insulin in 2018. So the same insulin, the cost goes from, in Turkey, the equivalent of $2.64 for a unit of insulin, to in the US, $98.70 for insulin. And that was in 2018. And the costs have gone up significantly since then. So I had to Google, how much does insulin actually cost to make? And I couldn't find the per unit cost. And I don't know how many units come in a vial of insulin. I assume a good number of them. It turns out that for the pharmaceutical companies, it costs between $2 and $4 to make a vial of insulin. And they say that a patient who requires insulin can have annual costs of, close to $10,000 for something that costs a drug company $2 to $4 to make. So corporate control and influence of pharmaceutical companies in the government is an ethical concern. The idea of making the genetically modified insulin was to make it accessible and affordable for people. We can also think about food security. Do GMOs help solve hunger and malnutrition? Yes. But do they also increase reliance on companies and provide corporate influence in a lot of different spheres? And animal welfare. How are these genetically modified organisms, these animals, being treated? And I think this is kind of an extension of just any sort of, animal welfare and animal testing. These animals need to be treated appropriately, and experimentation should be limited to only what's necessary. That's just my opinion. Okay, so regulation. In the US, there are 3 agencies that can regulate GMO safety in various combinations. The FDA, so the Food and Drug Administration, the USDA, the US Department of Agriculture, and the EPA, the Environmental Protection Agency. They all regulate GMO safety. As of 2022, GMO foods, or foods that contain GMO derivatives that would still have like the DNA, if they're super, super refined and don't have DNA anymore, like high fructose corn syrup and things like that, they don't have to be labeled. But if they might still have DNA from the original GMO crop, they have to say bioengineered. So bioengineered or derived from bioengineered ingredients, it has to say something like that on the label, unless it's less than 5%. That's how they get you. Things can also be labeled trans fat free as long as they have less than 0.5 gram of trans fat per serving. Okay. And that's just in the US. In the European Union, they're very strict. Many GMOs are banned, or they are really severely restricted. So this graph kind of shows you, and it's a little bit out of date. It was hard to find today's graph. But for the most part, this is going to be pretty accurate. What different countries do in terms of laws regarding genetically modified organisms. So these countries in red, so the European Union and New Zealand, you have to say anything that has any sort of editing, whether you used CRISPR, whether you inserted a gene, like whatever you did. If you did something that made the plant different from what it used to be, that is a genetically modified organism. All of the countries in yellow are still discussing what they want to do. For example, Norway is putting forth, or they probably have put forth, I just didn't look it up, a proposal that as long as you didn't insert foreign DNA, so all you did was like maybe use CRISPR, but you didn't insert anything, if you just deleted, no foreign DNA, not a GMO. Everything with foreign DNA would have to be a GMO. The UK, who knows what they decided to do? They did the whole Brexit thing. So most of the countries that are, in yellow are kind of thinking, well, as long as you don't add something, if you just use CRISPR or something like that, we won't call it a GMO, but everything else would be a GMO. But in India and Bangladesh, they were talking about, well, if you do anything, the proposal is maybe we call it a GMO. In Canada, they are not regulated unless a trait is identified as novel. In the US, something to be labeled bioengineered, as long as it is not transgenic, you didn't insert a new gene, it is not regulated. Okay, so just so you know, that's what the law is. So what is the future of genetically modified organisms? I think that a lot of companies are going to more heavily rely on CRISPR because it can allow modification without addition of new DNA. People tend to find that less controversial. Again, if you're talking about back in the 90s, that flavor saver tomato, if all we did was just delete the gene that causes them to rot, I'm okay with that. I think most people are okay with that. What they're less okay with is I inserted a new gene to interfere with the gene, and right? So I think a lot of companies are going to go this way because one, it's less controversial, and two, they don't have to label their products if that's all they do. Another application of kind of genetic modification, things like lab-grown meat to improve animal welfare and reduce the environmental impact of conventional meat processing. So that's meat grown in a petri dish. There's going to be more modification of crops, especially to improve climate resilience. So, we're having a lot of drought and then like these really crazy rains and like fires and all of these kind of climate change mediated events that crops can't necessarily withstand. I mean, growing up in the valley, maybe you're aware that one of the biggest crops in the valley is almonds. And I mean, the almond farmers get themselves in a tizzy if there's like an early freeze, or I'm sorry, a late freeze, or a big storm in February, because if it knocks the blossoms off the almonds or it freezes the blossoms, I mean, they're toast. They lose their crop. And almonds take up a ton of water. What if almonds could be engineered to be more drought tolerant or water efficient? And maybe the petals could be a little bit more wind resilient, right? And finally, synthetic biology, basically creating a new organism. And this is done at the microorganism level. But create new microorganisms to do things like produce biofuels, which may reduce our dependence on fossil fuels like and gasoline, things like that. And again, bioremediation, creating organisms that can clean up pollution. And that can include oil spills, but one of the other things to think about are things like styrofoam, diapers. They say disposable diapers take like 10,000 years or something to degrade, because there really are no microorganisms that are capable of degrading the artificial chemicals that have been made, the synthetic chemicals that make up something like styrofoam or a diaper. And I'm sorry, man, twins go through a lot of diapers, and I have contributed to that. But if scientists could engineer bacteria that are capable of degrading things like styrofoam or diapers or other plastics, that would be wonderful for helping to clean up our environment. So these are just some of the potential future directions and ongoing research with genetically modified organisms.